Hello. Today I want to do a little test with some capacitors. I would call the video fun with capacitors, but I don't know that everyone's going to really find this very much fun. It's a very short video. There'll be no math involved. I just want to take a look at what happens to frequency when I change the frequency through a capacitor, what the output looks like. You can see the little circuit there, and it's very simple. I have one capacitor. It's a about a 3,000 nanofarad capacitor, and then it just goes through like an 8 ohm resistor to simulate, let's say, a speaker or anything along those lines. And then I get a whole bunch of leads there that make it look really ugly, and that's just because there's 2 leads from frequency generator and 2 from scope. And the scope will be both before and after the capacitor, so we can kind of get a look at that. And then I'll play with the frequency a little bit, and we'll just see what happens. So while I reposition the camera to move into the scope and the frequency generator, I'm going to pause it. Okay, so there I try to get both the scope and the frequency generator, or the signal generator rather, into the picture. So I'm going to move over here and start to turn some things on. So the first thing I turned on there was channel 1, and that's set at looks like 14,000 kilohertz. I just kind of picked any random frequency out, and I'll kind of make this fit on the screen a little bit better. And what you can see, same circuit, but it's not to a point yet where that capacitor is going to start to let any of the AC flow through it. So let me get some other stuff set and ready to go. Sorry about the pausing so much, but space is limited. So like I said, I have channel 1 is kind of as if it would be hooked up right to the frequency generator. Channel 2 is actually, it would be at the load resistor, so it'd be in between the capacitor and the resistor, not on the ground side obviously. So I'm going to start to increase the frequency a little bit here, and we'll go, we're at 14. Keep an eye on the purple lead. That is the lead after the capacitor. That'll start to show you when the signal can start to move through the capacitor. The capacitive reactance will start to drop. And as you can see, it's starting to happen. Now you'll notice that the yellow signal, which is the channel 1, that's also starting to decrease as this one increases. The reason that's decreasing is because it's basically now completing the circuit. Before it was like an open circuit. Now it's starting to be generally a circuit because there's going to be the capacitive reactance and then the load, whatever that would be, and then ground. So kind of like the difference between when you're just checking battery voltage static or when you actually connect the battery to something. So you'll see as I increase the frequency, it starts to go up, and at one point they get to be about equal. So what I want to do now is add another capacitor in parallel, and I think that was the other one I had, so like a 0.01 microfarad. So I'm going to turn the camera over that way so you can get a look at what I'm talking about. Right over. Come on. Sorry about moving the camera so much. Try not to make you sick. Okay, so there's the board, and you can see this one capacitor here now. Now all I'm going to do is plug it in right in parallel, right beside the other one, and as capacitors in parallel go, they actually increase just the opposite of resistors. So the total capacitance will increase. So while I do that, I'm going to turn you back over to the scope, and we're going to actually knock the frequency back down again. We'll start again at our 14 kilohertz point where we were before, just so we have that same starting point. Since I already started at that, that's where we'll end up. So let's see. Okay, so there it is again. You can see the purple signal has all but gone away. So what I'm going to do is now, excuse my reaching around to the camera here. Maybe I can get on the other side and do this without. Yeah, so what I'm going to do is I'm going to plug this right in here. Come on, there you go. So, looks like we're already starting to see something, the response there. At actually a lower frequency. So there's already 24 kilohertz, and you can see the frequency response is just about all the way through. I'm going to speed it up a little bit so that you can see it on the scope better. As you can see, and then the same will happen as it happened before as I continue to increase. Oop, wrong way. 34, 44, 54, and you can see so the question you may have is, so why do I need a capacitor? What good can a capacitor do me? And my solution to that is what I'm going to do is flip on the second channel, and when I do that, let's just see what happens. Now it gets kind of ugly here, so I'm going to turn the one off. I'm going to turn this channel off. This is just the channel right coming out of the generator, just before the load or anything. And you can see the ugly waveform, and the reason it's an ugly waveform is because there's actually two waveforms in there. And if I speed it up enough, you can kind of start to see there's the one. It almost looks like a modulated waveform, and it is, so to speak. So, let's just say you have some kind of noise on whatever you're trying to do. And what I did here was I have our standard 2400 kilohertz signal that we had before, but then I'm also putting in a, let me see what I have on the other channel. On the other channel I have a 500 hertz signal. I don't know really what would bring up 500 hertz, maybe some type of noise from a computer or a light ballast, whatever, and you're just looking to cut that out and have it not in your signal anymore. So all you have to do is you can calculate the capacitor reactance, and like I said, we're not going to go into math this time. But anyhow, let's take a look at what the output signal looks like and what we can do with that. So like I told you, there's that one, and you can see it's kind of ugly. Here, what that did was it took out the 500, so I'm going to put just the 500 in and show you. There's just the 500 signal, and here it is out of the generator, and there's almost nothing there. So you see, again, just another way to use a capacitor as a filter. So here's both of them, and you can see, now if you watch and I start to drop down the frequency, I'm going to have to drop pretty darn low, but you're going to see that this one here will go away. So we're down at looks like 2000 hertz. And then as I go and bring the signal back up, sorry about that, but the meter kind of, or the frequency generator kind of changes decimals on me every now and then. So you can see there's again the signal with all the noise in it, and as I speed it up to a certain point, you can see it. And there it is in all of its glory. Oop, wrong way. With it out, and all that is just one simple capacitor to do that. So again, something you can try, just something I wanted to try and see how it actually looked on the scope. But that's all I have, and that's, I promised, no math, and that was it. Fun with capacitors.